Sir, expect it to how if you do this, sir. Wait till the class come here, put up work. You never say good evening or
No,
nothing.
so you need to say good evening too.
Wait, you said good evening, sir?
You never seen if you say good evening too. The three will come on same time.
I was here.
Because
I was here, and then Shanique joined, and then I don't know when you came in.
no. All three of us came in at the same time because we joined before 5 o'clock.
Yeah. But sir, me never see you, sir.
I saw you and Shanique on the phone is silent, so I said I go silent too.
Okay,
You
okay.
didn't lie.
You're full
Good
of
evening, Miss Bailey. Good evening to you too, Miss.
you're full
No,
of
no, no. Them say early bird catch a worm. So since you're there early, you get a head start. So if you want to wait until the others come, have it your way. The Burger King way.
All right, let me try. Let me attack it.
Yeah, man. Same as so. All right, so those of you who were here from early, um,
So message.
yeah, is it I'm reading, but look at don't look at that one. Look at the one before, Tevin, because I saw it.
The one before is functions as well, sir.
No, no, man, I saw the one that I mistakenly labeled as calculus one.
Okay.
It is really pre-calculus.
Alright, I'll take a second look then.
Please, yeah. So I realize that it's pre-calculus, but I mistakenly labeled it as calculus one. Just double check again for me, please, and let me know. I need
Yes,
to go
sir.
in and I'm in the train. Thanks for the heads up, though. All right. Those of you who came in early, have you completed the first one?
No, sir.
Okay. How far are you, Shani?
Sir, can I keep skip number one still? I'm gonna start number three now.
Okay. All right, so I need to move on, and I'm not going to spend a lot of time on this. So please, guys, I'm gonna come back at 5:30. Do one of the questions, leave the other two for you to do for homework, and then I'm gonna move it. We're moving on, please.
Alright, sir.
All right, so let's go. Those of you who are just coming on, big up yourself. Those of you who've been here, it's time to go. Let us do. All right, so tell me now, what should I let y be equals to?
Two x. 2 to the power x.
Okay, 2 raised to the power x. I would agree with that. So I'm going to let y equals to 2 raised to the power of x. So therefore, y squared is going to be equals to what?
Two to the power x. And 2 outside the bracket, you know.
Y squared equals 2 raised to the 2x.
All right, so in completion, I heard when he said 2 to the power x, but it's 2 outside. But the final thing is 2 to the 2x.
Okay.
Yeah, you must remember that. Please and thanks. Right, let's go. So now I'm going to have 5 times what?
5y squared
Y squared
minus 14y.
I need 2 factors. When multiplied together gives me negative 15, but when added gives me a negative 14. What factors are they?
So you say if you're negative 15,
Yeah. But when added gives me a negative 14.
Minus 15, sir. And 1.
Okay, good. I'm going to have 5y squared minus 15y plus y minus 3 equals 0. Then I'm going to group. And in grouping, five y squared minus 15y in one bracket. Leave out the middle sign every time. And then y minus 3 equals 0. What is common between 5y squared and 15y?
5.
5.
Why, sir?
Five Y.
Thank you. 5y is common. What is left?
Y plus
Y what?
minus 3.
Right. Y minus 3. What is common between y and negative 3? What is common between y?
Negative 1, sir.
Negative 1, okay. Why negative 1?
Sir, ask me because
That's
ask
a
me
positive
answer.
1.
Positive 1.
Mhm. So y minus 3 is common, and 5 minus y. 5y plus 1 is the other factor. So either y minus 3 is going to be equal to 0, and that implies that y is equal to positive 3. So that's one value of y. And then you also have 5y plus 1 equals 0, and that implies that y is equal to negative 1/5. And that's the other value of y. No.
Sir,
Mhm.
I use plus 1 minus 15y, but then I end up with the same thing that you have now. The 5 plus 1 and the y minus 3.
But that's exactly what I use. Except you use plus 1 and negative 15.
But because I use the plus, yeah, but because I use the
plus
plus
first,
1, yeah.
I always say it doesn't make a difference. 2 plus 3 is 5, and 3 plus 2 is 5. Addition is commutative. It doesn't matter which of them you use first.
All right.
Sir. All right. So when I just want to go up to the top part with the factors. When I multiply negative 15 times 1, I got what again? Negative 15. Is it something I'm not getting up there because am I supposed to get a negative 3?
No, you're not supposed. Which negative 3 talking about, Kevin?
And the negative 3 beside the negative 14. Why?
That's in the question.
This is the question, you know. That's a question, you know. Look back at the question. 5, open bracket, 2 to the 2x, close bracket, minus 14, open bracket, 2 to the x, minus 3. So all I'm doing is making a substitution for 2 to the x and 2 to the 2x.
Okay. Thank you.
So if I heard you right, Kevin, your factors are correct, because I heard it's a 15 and 1, negative 15 and positive 1. Yeah, man. So we multiply the coefficient of y squared, which is 5, by the constant, which is negative 3, to give us negative 15. So our product's supposed to be negative 15, but our sum supposed to be negative 14. So because I want a negative answer, it means that my bigger numbers are supposed to be negative. So we have negative 15 and positive 1. May I continue?
Yes, sir.
So now, recall. Y is equals to 2 to the x. So now I'm going to have since y is equals to 3, but y is equals to 2 to the x, I'm going to have 2 to the x equals 3. I have a simple indicial equation. Since I can't write the left-hand side in a base, looking at the right-hand side, I have to use logarithms. Since I can't write the left-hand side in a base on the right, that looks like it, I have to use logarithms to solve. So I'm going to say x log 2 is equal to log 3. And then I'm dividing both sides by log 2. What is log 3 divided by log 2?
Log 1. And divide this. Divide. You subtract that, sir?
Log 3 divided by log 2.
1.584 or 1.56. 1.6.
1.58.
1.58. Let us
Yeah.
have a little fun. Two to the x equals 3. What if x were 0? What is 2 to the 0?
1.
1. Is this 1?
No.
So x is greater than 0, don't?
Yes, sir.
Right. And what is 2 to the first? 2 to the first equals?
2.
Still short, don't it?
Yes, sir.
So again, got 2 to the third. Sorry, 2 to the second. 2 to the second equals?
4.
4.
You pass it now, don't?
Yes, sir.
So this based on little test that we just did a while ago, tells us that our answer lies between 1 and 2. So me getting 1.58, I believe that answer because when I did it in my head, it tells me that my answer lies between 1 and 2. Can't pass 2 because 2 squares is 4 and 4 cannot be equal to 3. Follow me?
Yes, sir.
And since y is equal to negative 1/5, can I find the log of a negative number? Can we
No, sir. Say it's unsolvable.
no solution? And that's the end of the question. So everybody with me so far? Can you see how not difficult the question is?
Sir, could you scroll up back, please? I want to ask something. Up to the top, sir. Yeah. So, where you have, let y equal 2x, sir. How
I
do
don't have
we,
it on the, I do not have that on the board.
y equal 2 to the x?
Power
Right, 2 to the x. Right, 2
Okay.
to the power of x, right. Continue
Yes.
talking.
Okay, so, I'm just wondering, like, how do you come about y equal 2 to the x? 2 to, yeah, to the x
All right,
power.
hold on. Press one, pause. Were you here the last class?
Yes, sir, but I have connectivity issues, so it goes in and out.
Yeah. Good. All right, I'm gonna be, but guys, I really can't be going back in. I spent an extensive class time last class, Tuesday of this week, and I went through it, but I'm gonna go through it again. Please make sure you catch it this time, guys. I'm moving on tonight. I'm moving on tonight. So I'm looking at the question and I'm recognizing that there are two substitutions that must be done. I'm looking for the small of the two to let y equals to that one. And if you look at this one, this says 2 to the 2x, and this says 2 to the x. So I'm letting y be equals to 2 to the x. And if y is equals to 2 to the x, when I square y, y all squared is y squared. 2 to the x all squared is going to be equals to 2 to the 2x. Can you see that law in indices?
Yes, sir.
Right. So when I square 2 to the 2 to the x, I'm going to get 2 to the 2x. So now I have a substitution for y equals 2 raised to the power x, and y squared is equals to 2 raised to the power of 2x. And from there, I'm going to go back to the original question and make the appropriate substitution. 5 is just 5. 2 to the 2x. 2 to the 2x is equals to y squared, so then call it 5y squared. Minus 14, 2 to the x is equals to y, is 14y. The negative 3 stands alone. Put it back. So does the equal 0. Write it back. Then now here, I have me a quadratic equation. Multiply the coefficient of x squared, y squared, by the constant. Find two numbers. When multiplied together, we'll give you the product, which is going to be 5 times negative 3, which is negative 15. But when those two numbers are added, I must get negative 14. The only pair of numbers that can give me the answer is going to be negative 15, 1. All right. And then we're factorizing, we're grouping 5y squared minus 15y in one bracket. Leave up my middle sign every time. And the y minus 3 is in another bracket. Equals 0. What is common here? That is common here. Would be 5y. 5 is common to 5. So it is to 15. And you can clearly see that the y's are common. So I'm taking up my 5y. When I remove 5y from 5y squared, what is left? Only one more y. So I write it down. When I remove 5y from 15y, what? Negative 15y, what do I have left? A negative 3. I put that down. What is common between y and negative 3? Nothing, sir, not true. One is always a factor of everything. So in a case like that, when you're not seeing something like that, trust me, there's a one that is there. So that's why I have this one here, and then I write this back. What is common here? That is common here would be y minus 3, which is here. What is left? Will be this 5y and this positive 1 equals 0. Remember, you're given an equation. Once you say something for you to solve, it has to have an equal sign. Doesn't necessarily have to be given to be equal to 0. If it's not given to be equal to 0, you'll have to transpose. But you have to always remember to keep that equal sign in it. And then either y minus 3 equals 0 or 5y plus 1 equals 0. Y minus 3 is equal to 0, that means it implies that y is equal to positive 3. Right here, so. And if 5y plus 1 equals 0, which implies that y is equal to negative 1/5. Right. Right here, so. Any questions?
No, sir.
Okay. So now we need to solve those two. They never gave us y in the question. We were the ones who introduced y. So I had to take it back out. But we know that y is equal to 2 to raised to the x power. Not 2x, but 2 raised to the x power. So we're going to substitute this y for 2 to the x equals 3. We need to find the value of x here and solve it using logarithms. You cannot take the log of a negative number, hence that one is no solution. Moving on. Which of those two is simpler? Look at question 2, guys. What am I substituting for?
3x, y equals 3x. and y squared equals 3 raised to the power of 2x.
But I'm substituting y4.
You're substituting y for 3x and so.
No, man.
No. You're talking number 2, sir?
Yes, ma'am.
You're substituting y.
3 raised to the power of x.
Thank you. 3 raised to the power of
3
x.
raised to the
Dahlia
power.
is not 3x.
Sir, God.
Not 3x. And you all are keep saying, not all, but you most are saying 3x. I don't have 3x on the board.
That's what I said, no mess. What?
So I'm going to get y equals 3 raised to the x power. Therefore, y squared equals
3 raised to the 2x. 3 raised to the 2x.
Thank you. Now, y squared minus 12y plus 27 equals 0. I'm multiplying the coefficient of y squared by the constant. What's the coefficient of y squared?
One.
Thank you. 1 times 27 is 27. I need two numbers. When multiplied, give me 27. But when added, gives me a negative 12. What two numbers are you thinking of?
9 and minus
Very good.
3.
Then I'm in group. Y squared minus 9y. Always leave the middle sign out. When I leave the middle sign out, something happens. What happens to this sign right here?
Negative.
The sign changes. So it's no negative. Whatsoever sign that is here has to be the same sign that is here. Let us check this now. Negative 1 times 3y is negative 3y. Negative 1 times a negative 27 is a positive 27. What is common between 9y and y squared?
5.
What is left?
Y minus 9.
What is common between 3y and 27? Huh?
3, sir.
9, sir.
3. Can't be 9. What is left?
Y and minus 9.
What is common between the two numbers?
9.
9.
Y minus 9.
Thank you. to either y minus 9 equals 0, it implies y is equals to what? Hmm? Yo, students, you don't make me feel tired, man. Come on, talk to me now, man.
Y equals 9 and 3.
Good job. So y minus 9, right, is 1 minus 9, but y is equals to 3 to the x. So 3 to the x is equals to 9. What can I do?
And simplify 9, sure.
As?
3 squared.
Good job, Papa. Therefore,
X equals 2.
um, y equals 3. 3 to the x is equals to 3. What do I write?
X equals 1.
Because 3 is the same thing as 3 to the first power.
Yes.
So therefore, x is equals to 1. Any questions? I just waited 5 minutes and nobody answered the question I just asked. Students, if you don't want to have a class, just let me know, please. But I can't be struggling to be teaching and asking questions and asking the questions and then answering them myself. It's not going to work. Really not going to work. I'm struggling, and God knows I'm struggling.
Sir, I'm not sure if it's just me, but I'm pretty sure you were muted all along.
I muted myself because I asked a question and nobody responded to me.
Oh, I didn't hear. Oh, my bad.
Didn't hear, sir.
Can continue. What do I do here?
Let y square equal 2 to the 2x.
Why we so quick?
Then, sir, which question I asked then? I'm trying to understand what I asked. Y equal
Okay.
Y would equal to 2x.
No, ma'am.
2 to the power x.
2 to the
Thank you.
power, yeah.
Therefore, no, come and tell me now. Therefore,
Y raised to the second power equals 3 raised to the second power x.
Y equals
No,
2 to the
2 to the 2x.
2x raised to the second power 2x.
good. So substituting now, I'm going to have what?
y squared plus 4 bracket y plus 3 equals 0.
And multiply the coefficient of y squared by the constant. 1 times 3 is 3. I need two numbers and multiply together to give 3, but when added will give me 4. What two numbers are you talking about?
Minus 4 minus 1.
Say that again.
Minus 4
Positive 1 and 3.
and
Let's start it. So the factors are positive 1 and 3. So now I'm going to have y squared plus y plus 3y plus 3 equals 0. I'm in a group. To give me y squared plus y plus 3y plus 3. What is common between y squared and y? What is
Y.
left? What is left?
Y.
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 What is common between 3y and 3?
3.
3.
Good job.
3.
What is left?
Y plus
Y
1. Y plus 1.
plus 3.
Plus 1.
Y
Plus
plus
1.
yeah.
what is common there now?
Y plus
Mhm.
1.
Y plus 3 and Y plus 1.
Good job.
Sir,
Mm-hmm.
so when you factor out the common things,
Mm-hmm.
you only leave what, well, it has to be the same as the other side, you say, right?
Mm-hmm.
So you take out what is common, which would be the 3, and leave the Y plus, and put back the 1. But how you get the 1? Do you just put back the same thing that is on the other side?
Yeah, because you're factoring out what is common between this and that, and it's Y plus 1.
Okay.
So you take out the Y plus 1 here, what is left? This Y. And put it here. You take out the Y plus 1 here, what is left? Plus 3. And put it here, plus 3.
Okay, sir.
Mm-hmm.
Now this table, you see up at the top, we have y squared plus 4y plus 3 equals 0. And then underneath it now you have y squared plus y. But what the 4? I don't understand how you come by right this one.
1y plus 3y equals 4y.
4.
I'm breaking up 4y.
Right, so you're breaking it up.
Oh.
So 1 plus 3 equal 4. So you just break it apart.
You get 2 numbers out, I'll give you the 4.
Right.
Yes, ma'am.
Oh, that's what I didn't catch. Okay.
Rockstone. So that's so much long you never catch it?
Yeah, me I struggle still, but I just look and talk about when
that was the question I asked when I muted myself for 5 minutes. Are you understanding?
Sir? Sir, I
Say it again.
honestly believe you were muted when you asked that question, because the last thing you said was the answer to the last question.
No, Diana. The last
No,
thing I
he
said is,
actually asked for you.
Really?
I asked the question. Yes, I did. I asked the question. I had any questions.
Didn't
I
hear
asked
that.
the question. Yeah, man. And that's why I should ask nothing more. All right. So you guys just need to listen. Because really and truly, I shouldn't be pausing and questioning you as we go along to say, are you understand? Are you understand? You are supposed to be responsible enough to say that, sorry, I'm not seeing something, and allow me to go through it. But because I know how the things are, I'm gonna go to work and I'm tired, and I don't really know I have no maths class, you know, but I'm doing what I'm doing. But you not have to be alert, because if you don't do it, you're not gonna make me drop asleep. All right, let's go. Continuing. So I'm gonna have either y plus 1 equals 0.
First answer before you continue. We have to write either and all these things when we're working this question to write.
Yes, miss.
Okay.
So either y equals what stone? I was going right here, so either y is equals to -1. But what was y again? Y was equals to what? 2 to the x, don't. So we're gonna have 2 to the x is equals to -1. What do we say?
Solution.
Huh? Say it again. No solution. And then I have now y plus 3 equals 0. Y is equals to -3. 2 to the x is equals to -3. What do I say here?
No solution.
No solution. Why? You cannot take the logarithm of a negative number. You cannot take the logarithm of a negative number.
Question, sir.
Go ahead, please.
This part, how do you get the -1 and the -3 when you have a +1 and a +3 at the top?
Y plus 1 is equal to 0. I want to find the value of y. So I'm going to say y plus 1. And I need to leave y alone on one side. That means that I have to subtract y from both sides. So -1 And then it's going to be equals to 0, but because I minus 1 from that side, I have to minus 1 from that side. So I have my y plus 1 equals 0 in red. But I want this to go, so I'm going to subtract 1 from both sides. So when I subtract 1 from both sides, those cancel out. So I'm going to end up now with y. What is 0 minus 1? Minus 1. Which is this. I'm solving for y pretty much.
Okay, sir, so if you had a -1 there, why -1 instead of +1? Would it have been the other way around? You would have to, what, do the opposite?
Yeah, I added 1 to both sides, right?
Okay.
Yeah, 500? Yeah.
All right. Are we okay?
100%.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. All right.
Boy, yes.
Unit 2 is only just now finished. Unit 2 is now finished. On to Unit 3. I'm on to Unit 3. Are you still seeing my screen?
Yes, sir.
Yes, sir.
I'm looking at binomials. I'm looking at binomials. What does bi means?
Two.
Two.
2. Means 2. I'm going to see if I can develop this topic by saying to you or asking you a plus b raised to the 0 power. And that's where the by comes in. The by comes in with the 2 terms inside the parentheses. Right? That's where the by comes in. The 2 terms in the parentheses. A plus b to the 0 equals what?
One.
Good job, good job, good job, good job, good job, good job. Anything raised to the power of 0 equals?
1.
1. Watch me now. A plus b raised to the first power equals what?
A plus
A,
B.
B, A plus
A plus b. Excellent. A plus b to the second power equals what?
A
A
plus
plus
B
B
squared.
squared. AB squared.
Think
A
about it.
Write it 2 times, sir.
You can write it 2 times. You can write it as a plus b times.
A plus B.
Work with me now.
Okay.
A times a equals?
A squared.
A squared.
A times b equals?
AB. A plus well,
B times a equals?
BA.
Same thing as ab, don't.
Yes, sir.
And b times b equals?
B squared.
Good job. How many A squares I have there?
1.
Good. Really? So 1.
1.
So we go write 1. How many ABs we have there?
2.
And how many B squares we have there?
1.
Can everybody see that?
Yes, sir.
I have 1 A and I have 1 B. Are you with me?
Yes, sir.
All right, work with me now. I can put on a big one on you.
Channel.
A plus B to the 3rd power. How can I simplify that?
A plus B
A plus B
times A
bracket.
plus B times
A plus B bracket. A plus B bracket.
One more or 2 more?
1 more, sir.
1 more.
But did you work out A plus B already?
Yeah.
And then we get A squared plus 2AB plus B squared. Talk truth.
Yes, sir.
Yes, sir.
So just need to multiply that by A and 1 more A plus B, don't?
Yes, sir.
Work with me. A times A squared equals?
A
A
raised
to the 3rd.
A cube. All right. All of you pay attention now. I don't want to finish. You say, sure, I don't see it. Pay attention. A times A squared gives me A cube.
Sure, you move fast.
Okay. A plus B all cube.
AB.
We agree that it is A plus B times A plus B times A plus B.
Yes, sir.
Okay. Do you also agree that A plus B times A plus B up here? So I work it out already and got A squared plus 2AB plus B squared, which is in this parenthesis right here. Do you agree with that?
Yes, sir.
Okay. Is there anyone in the class that don't see that? Okay. What is A times A squared?
A cube.
What is A times 2AB?
A square plus B. A square B.
A times
2 A cube B.
2A squared B.
A squared B.
2A squared B. Good job. What is A times B squared?
AB
squared.
Good job. AB squared. I'm finished with all the A's. Talk truth.
Yes, sir.
Yes, sir.
I'm down to the B's now. What is B times A squared?
BA squared.
A squared.
BA squared. Don't.
Yes, sir.
Yes.
It's the same thing as A squared B?
Yes, sir.
All right. What is B times 2AB?
2B squared.
2AB squared.
2AB squared.
Good job. What is B times B squared?
B to the 3rd. Or B cubed.
I'm adding. How many A squared A cube I have?
How many you
1.
want, sir?
1. How many 2A squared B plus A squared B equals?
3A squared
What?
B.
Sir, ask the part there again.
Yeah, I'm not hear what you say.
Right.
A squared B plus 1A squared B equals?
A squared B plus 1A.
Oh, I see it now, sir. So it's 2A squared plus A would that give you 3A squared.
B.
And then B.
3A squared B.
1A squared B plus 1AB squared plus 2AB squared equals?
3AB squared.
3AB squared.
How many B cubes I have?
1.
I must do something. I not no more.
Sorry, can go over
Sir,
from the division side. I get disconnected at 2AB squared.
I don't have no division.
Division.
I'm
Alright,
adding.
yeah. I got disconnected at 2AB squared.
What is A cube plus 0? Smith.
A cube.
Plus 0.
A cube.
Good, sit here.
Plus 0, sir.
Yeah.
A
What is
cube 0.
what is 2A squared B plus 1A squared B?
2. Where's it, sir?
2A
I
squared.
using my phone and not the laptop, that's why.
No man, just look on the, just put it on speaker and look. Nobody put it on your ears. Put it on
But sir,
speaker.
I'll make an earphone put it on my ears. What you said? 2 1.
Put it on speaker. You can't go on speaker. Abang I have?
Sir, what you ask?
You have to look at the screen to see what I'm pointing at.
Okay, go ahead.
2A squared B plus 1A squared B equals
3.
3A
Okay,
squared B.
sir, that's what I was wondering.
yeah.
How you get the 3?
Yeah.
Some say you get the 3 now.
I'm
All right.
following now, sir.
Good. See, that's something so much look. Watch me again now, pumpkin. 1AB squared plus 2AB
Plus
squared
2AB squared equals 3AB squared.
magic. Let us go one more time. How many of this B cube that I have up here, so?
1.
1 B cube. You see that now?
Yes, sir.
Yes, sir.
Good job.
There, scroll up, please. Keep on something. Sir, yeah, roll it back down. I'm gonna screenshot it.
So, Lady B, that's what I'm on. You may have to roll it back, don't say you can screenshot the thing all together. You can't see that.
Someone got no.
You get it?
Call the phone.
Send it in the group, please.
Latisha, you see it? You get it no more?
Thanks.
No, was that a yes? You get it?
Yeah, I said yes, sir.
Oh, okay, good job. All right, let's go. Watch me. I don't want anybody to write it. Just watch me.
Sir, could you enlarge it, sir?
All right, as soon enlarge it, there's a point I'm trying to bring across. So my A plus B to the 0, I end up with a 1. So I'm going to write that 1 right here. So my A plus B to the first power so I'm arranging my coefficients. A plus B to the first, I'm going to have a 1 and a 1. The A plus B to the second power, what do I have?
1, 2, and
1, 2,
1.
1.
The other one, what do I have?
1, 3,
1,
3,
3,
1.
3, 1.
What do you recognize with that I have so far? What the shape looks like?
A pyramid.
A pyramid. Good. It's like a pyramid. Excellent answer. Looks like a pyramid. Are you seeing any relationship with a pyramid?
Yes, sir.
What relationship is it?
Each time you go down, the middle number is you add Let's say you add a 1 to the middle number, the semi go down.
You give me that 2.
Yeah.
And then
then
this.
And then 1 plus 2 give you the 3. And then the next 1 plus 2 give you the 3.
Okay. All right. Let me write one more. What would I have?
1, 4, 4, 1.
1,
4,
4, 4, 1.
6, 4, 1.
6, 1. Yeah.
Can you see that?
1.
Yes, sir.
The 3 plus 3 give the 6. Okay. And then the 3 plus the 1 give the 4. Okay, so the 1 plus the 4 they give the 5. And then 4 plus, okay, 1, 2.
1 plus 3, 4 plus 3, 6.
Follow me now?
Yes, sir.
Helena, you see that now?
Yes, sir.
Yes, sir.
All right. Yes, this thing don't want to scroll at all. Okay. My singing Bob is frozen. Oh Lord. Not at this time.
Sir, 1, 5, 10, 10, 5, 1.
Good job. So now from that, I can get something that is called Pascal's triangle. One, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1, so forth and so on. So that's what Pascal's triangle is. Now you're going to be question?
No, sir.
Okay. So Pascal's triangle was generated from just getting the coefficients of the terms, that what you see me do here. So he recognized that if he has 2 terms, which is called a binomial, because when it is that we're looking at multiple terms, they are called polynomials. Poly means many. So when you're talking about a single term, it is called a monomial. If you're talking about a term with 2 things, it's called a binomial. If you're looking at a sequence of 3 things, it is called a trinomial. Can you see the gist?
Yes, sir.
Mono, 1, bi, 2, tri, 3. So we don't talk about quaternomial. It's the ones with more than 3. We just group one of them and call them polynomial. Poly means?
Many.
Many. All right. But this binomial now is going to be used particularly so that I can get my 2 terms and I can investigate what is happening. Raise it to the power 0, raise it to the power 1, and work it out. I guarantee you, my a plus b to the 4th power, with Pascal's triangle, I can easily expand that one. And let me show you what is happening. My a plus b raised to the 4th power, what it is that I can say to you is that because it's to the 4th power, it means that I'm going to be using this term. How you know, sir? Because you look at the second value. You recognize that the first value and the last value are the same?
Yes, sir.
All right. So let me just give you a little story. So those are called palindromes. What are palindromes, sir? When you read it from the left-hand side to the right-hand side, you get one something. Watch this. 14641, 14641. You see that?
Yes, sir.
Yes, come on. 15101051, 15101051. So when you can read it 2 ways, you get the same thing. Let me give you some English one for argument's sake. R-A-C-E-C-A-R. When you spell race car, one way go so, you get race car down.
And
Yes,
say,
Put it that
wow,
way
I
then
didn't
to
even
make it.
realize that.
Let me give one next one. L-E-V-E-L. When you read it one way, you get what?
Okay, sir, that really level.
You get level, right. So you see, mathematics is one big something. It's a big deal. It is a big, big deal. That's why when sir talking in a class, you class with her because you can learn something new. So those are called palindromes, right? And you can go find, there are others out there. Me can't bother telling no more. There are others out there. You can go find and come class, come show off one way. So these are called palindromes, all right? So now, look at what is going to happen. We have a plus b raised to the fourth power. I can use, so you recognize all of them, the start and the end, they both have 1. Every one of them start with 1 and end with 1. You can see that?
Yes, sir.
Good. So in order for me to know what power I'm in, I have to look at the second digit, either from the left or the right. So me I look for 4, or no 1 4 you're gonna find in the something. Well, you see 2 of them because you know it's a palindrome. So if you have 1 4, you have a 4 the other end. So it means that because I'm here with this 4, that means this is what I'm looking at. So my coefficients are going to be 1, 4, 6, 4, and another 1. There are some things that I want to point out to you. I mean, I want nobody quint because you're not going to miss it and say, sir, we never see it. What is the power that the a plus b is being raised to?
4.
The fourth power.
What is the power the a plus b raised to?
Fourth
The
power.
fourth
4.
power.
You are going to end up with 1 more term. What you start talking about? 1, 4, 6, 4, 1. How many terms that?
5.
5.
Oh,
If I'm raising to the 5th power, how many terms am I supposed to have?
6.
Let us check. 1, 5, 10, 10, 5, 1. 6 that down.
Yes, sir.
Yes, sir.
If I raise it to the 7th, to the 6th power, how many terms I have?
7.
7.
1, 6, 50, 20, 15, 6, 1 is how much?
7 terms.
All right.
7
That's the
terms.
first thing I want you to recognize. The first thing I want you to recognize. The power that you're in, when we're talking about binomials, it is going to be, you will have 1 additional power.
Yeah.
Don't blink. Watch the second thing I'm going to point out to you. So if they give you this answer to expand using binomials, watch. Let me go up here and show you something. Let me show you something right here, so because I want you to see it. Hey, you. Watch this. You know that to the third, so we have 4 terms, don't?
Yes, sir.
1,
Yes.
2, 3, 4. So we're going to start with a cube. See the a cube, you go, boom, a cube. But what is going to happen now is that it's going to go down. That means I'm going to go down a to the 2nd power. Because I can't go up to 4 because I don't have the 4 up here, so talk truth.
Yes, sir.
Yes, sir.
So the powers are going to be shared between the 2 terms inside of the parentheses. When one give up 1, the other one will accept it.
Yeah.
So one has to give up something first before it can accept it. So the one and now I go down from a cubed to a squared. So you know it have a squared. The b better take up the 1. You know why? Because the sum of the overall powers must be equal to the power start off with. What is 2 plus 1?
3.
Good.
3.
That one are 3 down.
Wow.
So the one you
Yes,
know, the a squared better lose 1 more to come a. Talk truth, which is a to the first. The b better take more, so it can be from b to the first what? B to the
Square.
b to the
Square.
second. Yeah. The one you know, the a I go give up 1, so I go a to the how much?
3.
The 0.
Oh, 0, yeah.
A to the 0. That means b I go take up 1 more down.
Yeah, 3.
Yeah, man. Until you have nothing more to give. And it done right there. So can you see that?
Yes, sir.
Yes,
Let's
sir.
go to this one. A squared. A squared, it start off with a squared. Then you can go to the second term. That means you can lose one of the terms from a. So you're just going to have a to the first power. Talk truth.
Yes, sir.
B better take up the other one, don't?
Mm-hmm.
Because 1 plus 1 must equal 2.
Mm-hmm.
And then when you move from that 1 here now, A will give up 1, so A will be A to the 0, don't?
Yes, sir.
Yes,
And B will
sir.
take up the other one, right? So every time the sum of the powers must be equal to the overall power. Watch this. The sum of powers in this first term is 2. The sum of powers in the second term is 2. The sum of powers in this one is 2. Check this one. Sum of powers in this first term is 3. Sum of powers in the second one is 3. Sum of powers in this third one is 3.
Sir, you're pointing?
Sir, I
Not
got
pointing.
my
Sir, if you're pointing, we're not seeing anything.
I'm pointing, but you're not opening
Right.
eyes so good. So let me use a pointer. The sum of powers right here so is 2. The sum of powers right here so is 2. 1 plus 1 are 2. And the sum of powers right here says 2. The sum of powers right here so is 3. 2 plus 1 is 3. 1 plus 2 is 3. And the 3 are standalone. You see that?
Yes, sir.
All right, good. That's the second thing I want you to see now. That's the second thing I want you to see. So watch this now. Work with me. We say bright. So we are going to work this something now without even doing this something myself. We're not going to do no expansion because the expansion business is of the past. So the first coefficient, we're going to write it 1, and it's going to be A to the 4th. Talk truth.
Yes, sir.
Yes,
Good.
sir.
The A must lose 1, don't?
Yes,
Yes, sir.
The A lose 1, B are going to take it up, don't it?
Yes, sir.
Right, so watch this now. Plus the second coefficient, and this is going to be A to the 3rd, B to the
First.
1.
first. Good job. Good job. Then I write the third coefficient. Watch this. This is going to be A to the how much now?
A to
A to the second power.
And B to the
Second power.
Second power.
good. Done. Then we're going to write which now?
4.
4. Then we're going to write A to the how much in?
1.
1
Yeah,
power.
and B to the how much in?
Third
3.
power.
Good job. Then we write the 1. Then we're going to write what?
1 A to the
A.
0. A to
A
the
to the
0.
0 and
B to the
B
fourth
to the
power.
B to the
anything raised to the power 0 is?
1.
1.
1.
Very good. So that equals 1. So we can write it or we don't have to write it because I never did write B to the 0 right here. So but if I do want, I could put B to the 0. I'm going to write B to the 0 right here. So it's still 1. Talk truth.
Yes, sir.
Now watch me now. 1 times A to the 4th is A to the 4th. 1 A to the 4th. Plus 4A cubed B plus 6A squared B squared plus 4AB cubed plus 1B to the 4th.
Yeah.
It's a bright. That is the expansion. So we just use the information that we have, the coefficients number 1, that we have 1 extra term than the original power given, and that as 1 descends, the other ascends. Note, as 1 term descends, the other term ascends. Can you see that?
Yes,
When
sir.
1 term go down,
Another one go. Right.
so as 1 go down, 1 go up. And they have to work in sequence. You can't have 1 go down and the other one will come up. Because what happened? The sum of the powers must be equal to the power that you start off with. So this 4 is by itself. Because if I even put B to the 0, it is still 4. And if I put A to the 0, it is still 4.
Yes,
1 plus 3 is 4, 0 plus 4 is 4, 2 plus 2 is 4, 3 plus 1 is 4, and 4 plus 0 is 4. So the sum of the overall powers must be the same. It must be the same.
And in order for it to read both ways, sir.
Yeah. It's a palindrome. So it can be read both ways. All right. Are there any questions? Are you seeing what is happening so far with this is something here.
Yes, sir.
Yes,
It's not
sir.
hard. It not hard. Just trust me on that one. It not hard. Let me use the 9 minutes I have to generate another question. Incidentally, what I just did a while ago was one question. Eh? So let us do an example. I'm going to write example. I'm going to say expand.
Sir,
Yo,
I want you to clear up one thing first.
go ahead.
When you had said A plus B to the fourth power, you had said something and I'd missed that statement because when I looked at the pyramid, I saw that it was the fifth set of numbers that was selected in order to work out this expansion. I missed something I said about not the, I don't remember that part.
Me no remember what we said either. True, Caroline.
I'm following you so far, but you said A plus B to the fourth power, you said something and that you could use the fourth because when I looked at the pyramid, it was a fifth set of numbers that was used to break out the to expand this.
Okay, so what I was saying to you there, so is that if I give you something to the fourth power, you're going to have 5 terms.
Okay.
You're going to have one more term, right?
Okay.
So if I give you something to the sixth power, you're going to have 7 terms. Let us check. 1, 2, 3, 4, 5, 6, and 1, 7.
Got it.
Good. All right. So if I say expand 2x plus 3y to the third power in ASCEN in ascending powers of x. Rockstone. No, I'm going to put in descending powers of x. In descending powers of x. Means say x going to go down. So if x go down, that means y going to go up. Talk truth.
Yes, sir.
If I could give you the question and say in ascending powers, but I don't reach that part yet with you. That's a next class part. So we have 7 minutes now. We're going to work this one in 7 minutes. Work with me. I'm going to say to you, I'm in, what power am I into?
Cube.
Cube. So what are the coefficients?
1, 3, 3, 1.
Good job. 1, 3, 3, 1. And you know it have 4 terms because we're into the third power. That's the first thing we're going to do. Now remember, watch this. The 1, 3, 3, 1. I'm going to write down the 1. Then we're going to write, which is the first term?
2x.
So it's going to be 2x, and that is going to be raised to how much power?
3.
Talk through. Very nice. We done with that now? Say yes.
Yes, sir.
Yes, sir.
Oh, sorry.
Then the next coefficient is?
3y.
3. No, man. I have to use the coefficients first. 3. Then now I'm going to go to this. This was 2x to the how much?
To the third equals 2.
Good. We're going to have 2x to the what now?
Second power.
Good job. But 1 go down, so that means something must go up, don't?
Yes, sir.
So we're going to have 3y to the
1.
first power. Good job. Anything else?
3.
No, say no. Because 2 plus 1 is 3. So I'm going to put on the next 3 now. This 3 now I'm going to put on right here. So then what I write?
2x.
2x.
To the?
To the
To the first power. Good job. Then?
3y to the second power.
To the second
Good job.
power.
Then? Plus? Then?
1.
Then?
2x.
2y.
2x to the?
To the 0 power.
Then?
3y to the third power.
3y.
All right. Now, for those of you who are following, this is excellent. In your spot, sometimes it takes me a while to catch your so. And I start here so about 20 minutes ago. And those of you who are talking to me, very proud of you. Tiana, go ahead, please.
Sir, what about 3y raised to the 0 power?
I could write that.
For 1.
I could write that. If you want me to write it, I could write it. 3y to the 0. Yeah, I could write it. But by the time I do the question, you recognize this a term here and this a term here. When they start eat the dumpling and stop drink the milk, when I go recognize it, sure, we have to write that, sir. But yeah, if I want, I can write it because anything raised to the power 0 is
1.
Is 1. Yeah. So let us work out this now and finish up. We have 4 more minutes. This is going to become now 1 times, what is 2 raised to the 3rd power? 2 times 2 is?
8.
4.
4 and 4 times 2 is 8. So this is going to be 8. But remember, it's everything in the parentheses going raised to the 3rd power, you know. What is x to the 3rd power? Say x cubed.
Okay.
X cubed. All right. So what I'm saying to you is 2x to the 3rd power is going to be 8x cubed. Follow me?
Yes, sir.
Yes, sir.
Good. And then now, Tiana, I can say 3 to the 0, entering raised to the power 0 is
1.
1.
Is 1. Right. So 3 to the 0 is going to be
1.
is going to be 1. So I can put times 1, which will not make a difference. All right. And then plus 3. What is 2x to the 2nd power now? We're not going to do it singly now, but we're going to do everything one time. What is 2x to the 2nd power?
4x.
4x.
4x squared.
4x squared.
Yeah.
Can't leave out the square now.
Yeah.
Times, what is 3y to the 1st power?
3y.
3y. Good job. Love the sound of that. What is 2x to the 1st power?
2x.
2x.
Good job. What is 3y to the 2nd power?
3y squared.
9y squared.
Yeah,
Oh, yeah.
9y squared.
Yeah. Sorry.
Good.
Y.
This is 1
1
times, what is 2x to the 0?
1.
Good.
2x. 1.
2x to the 0 is 1.
Number
X to
raised
the
to
power 0
0
is
is
1.
1.
What is 3y cubed?
27y cubed.
27y cubed. Good job. Yeah, man. You call it 9, make me take away your lunch money for tomorrow. Call it 9, make me take away your lunch money for tomorrow. Okay. All right, so let's go now. So we're on to the last thing. 1 times 8x cubed times 1 is simply 8x cubed. Work with me now. What is 3 times 4?
12.
And 12 times 3?
9.
No, say 36.
12
9?
times
Wow.
36.
OJ, you have to go give me your lunch money tomorrow now, real talk. And then now you have your variables on x squared y. X squared y. That finished. But I'm doing the multiplication, you know. What is 3 times 2?
6.
And what is 6 times 9?
54.
54. And this is going to be 1x and a y squared. So x, y squared. What is 1 times 1?
1.
And 1 times 27 is?
27y squared.
No, say cube.
Cube. Sorry.
27
Cube. Sorry.
Good.
Cube.
So what is happening here now is the question says in
ascending, descending.
In descending powers of x. So descending, so x must go down. Look at check if x will go down.
Yes, it go down till it disappear.
Go down till it disappear. Very nice. So x cubed, then x squared, then x, then not x not about x to the 0. So that's what it means in descending.
That we like, so we like when the x them gone.
Yeah. So that's what it is. Right on the clock. It's 7 o'clock on the dot. And the class stop. Wait.
So you can zoom
I have
in
a
so we can
question,
see.
sir.
So I can take a picture, please.
Go ahead, OJ. Sure. Go ahead, OJ.
When you were doing the multiplications just now, you added for the second section you added the 3 times, you multiplied the 3 times 4 times the 3. So you multiply the 4x and the 3y.
Yeah.
Okay.
I did. Thanks, guys. This is good work. I will somehow get this to you in a few. I'll send you this stuff. Yes, please.
Still asking about the, I'm gonna call it now, midterm.
Right. So what I'm gonna ask you to do for me, thanks, Dee. What I'm gonna ask you to do for me is to prepare. What I'm doing here, this topic is also going to be included on the mid-semester. So the mid-semester is going to be units 1, 2, and 3. I think. Yes.
Lord
Units
have
1, 2,
mercy.
and 3. Yes, please. So I just start unit 3 and I'm going well with unit 3. So
Sir, me not fully understand unit 3 now.
no, but we just started.
We have more days to go.
You have more
Yeah,
to
me
know.
know, but me not breakdown. Me not fully get the breakdown.
No worry about it, man. You're gonna have one long weekend. Remember, so today the last class for the week, And then now, all we need to do, well, to be honest with you, all that there is for this topic is just to do more questions and then the topic done. And then
the same
binomials, yeah. And then I'm gonna and after that, now I'm just gonna show you another way of doing the binomials. And the topic finished. So the top is a short topic. Let me just show you quickly. I know you have another class. Let me just show you something quickly because Diana asked a question. Now, look here. Let me just do the question I just did. So I did a question. So sometimes what if I said to you, write down the coefficient of, or write down the third term in the expansion of 2x plus 3y to the third power. Instead of having to go do all of them something here, to get this 1, then this 2, to go write down the third term as 54x to the 54xy to the second power. I can just show you a nicer method that you can just go in at the something and just pick out that one here. So you have to write out the whole something. What if you tell yourself, I want something to the 20th power, and I want you to write on the term with the 16 something. You have to go do write down Pascals to the 20th power. No, sir. Matter of fact, there is no question that will go beyond 5 in Pascal. So you say I give you 1, 6, 15, 20, 15, 6, 1. There's no question that will be given you to do with Pascal's calculation that is going to pass 5. So all you need to know is 1, 1,
Sir,
1,
you're not
1,
sharing your screen, okay?
I know I'm not sharing, yeah.
Okay.
So it's going to just be 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. Instead of 1, 6, 15, 20, 15, 6, 1, you're not going to use those. But I did it. I wrote it a while ago because I wanted to see if you are seeing how it's that we got Pascal's triangle. However, them can tell if you write down a term in our Migla one term. You know, like it's like you see a mango tree. And you go under the mango tree, and when you look under the mango tree, you see the fattest East Indian mango ever. You know, have no worm spot, and it just saying to you, see me here, pick me. And you just go directly to the mango there and pick it, as opposed to the picking the young one, the motor doors. When I get to that one, you see what is happening. Do me a favor. We won't meet on, live. We have a class on Tuesday because I think we come back on Tuesday. Monday is a holiday, we'll come back on Tuesday. I'm going to encourage you to do something, guys. And this is my final lastly. For the foundation concepts 3, that just went. Some of you came over here pre-calculus because you did well on your coursework pieces. You did well on your coursework pieces. The exam wasn't so hot. What am I saying to you? Many of you know that you have a challenge with exams. So in Jesus' name, work hard on getting a very good grade for your mid-semester, because you don't know what the exam is going to feel like and look like and what it is that it's going to do to you. So if you give me a mediocre mid-semester grade, and then you give me and you fall on boof on your face in the exam, you are going to fail pre-calculus. Lastly, If you fail pre-calculus, there is no way come next semester, you're going to be allowed to do business calculus or business statistics. This course is a must-pass course. So you can move on to the other two courses come next semester. I don't want you to put off them courses here for the summer semester. The summer semester is too short. Business calculus, business statistics are 60-hour long courses. If you wait for the summer, you can put yourself under problems. What am I saying to you? Go study your book. Have a wonderful rest of the evening, my students. I'm going to send this off to you tonight, later.
Sir, when is the mid-semester?
I don't know. Study.
Okay.
Yeah,
Sir,
man.
sir,
Go ahead.
for the education, sir, I am doing over this course. I was wondering, based on the grade, let's say if it's not too bad from education.
No. The only way we can reuse the grade from EduConsult is unless you got a D plus and above. If you got anything between 45 and 49, you can carry forward your grade from EduConsult. If it is that you got a grade lower than 45%, you have to go over the pieces on Educo.
Okay, how do I go about doing that? Should I? What's the process in our grade? Because I actually really didn't know. I was
So
just
are you doing a resit or a redo?
redo, I think. Redo.
Right. A redo is if you got a grade less than 45%. If you got a grade 44, 45 to 49, it means that you're doing a resit. You just do the exam alone.
Okay.
But if it is that you have a grade 45, below 45, you have to do over the pieces on Edico and do over the mid-semester. You have to do, it's a redo, so you're doing over everything for the course. Come to class, do the mid-semester, do the pieces, and do the exam. Fair enough?
Oh, so yes, sir. But just the next question. So getting a grade in education, right? That is, let's say, acceptable, right? Or a pass, let's say, right? With the combination now, from the mid semester and the final exam, that's how you would determine now if that's the overall grade. So when you do the overall calculation, that's what determines if you have to do over education or
No,
the
it's a
individual
final
grade.
grade. So it's an overall final grade. So if you get, say you get 90% on EduCasoft,
Yeah,
and you get 90% for the exam, but you
yeah,
know for the mid-semester, but for the mid-semester, for the final exam, you get
yes, sir.
only 5%.
Yeah,
And you end up getting 43% for the overall grade. You
yeah.
still have to do over the EduCasoft pieces, and you still have to do over the mid-semester because your final grade was less than 45.
Okay.
All right, good. Understood, though, right?
Yes, sir. Thank you.
So, sir,
Mm-hmm.
good night. You have to go do work for EduCasoft this semester.
When you come class?
Sir, we never class long time, sir.
So, how many was you referring?
But through me come on a little late-ish, like after 6. I said, I don't want to disrupt by opening the mic and just.
Goodness, make bad mercy for you. Yes, refer. We ask you now. If I what?
If we ever go do work on EduCasoft.
Yes, sir.
All right, sir.
Big up yourself.
All right, sir.
Cool.